My dear students, in this video we are going to study about the structure and bonding in four metal carbonyl compounds. Metal carbonyls are the complex compounds formed by the carbon monoxide with the transition metal atoms. In these compounds, carbon monoxide acts as the ligand. In carbon monoxide, carbon atom as well as the oxygen atoms both have the lone electron pair on them, but the only carbon atom gives its electron pair for bonding. So that's why these compounds are known as the metal carbonyls. In this picture we can see the classification of the metal carbonyls. Metal carbonyls are mainly classified into two types. One is the mononuclear metal carbonyls and the other one is the polynuclear metal carbonyls. In mononuclear metal carbonyls, only one metal atom is present, whereas in the polynuclear metal carbonyls, two or more metal atoms are present. Polynuclear metal carbonyls are further divided into four types. They are the homonuclear metal carbonyls, heteronuclear metal carbonyls, and third one is the bridging metal carbonyls, and the fourth one is the non-bridging metal carbonyls. And again, bridging metal carbonyls are divided into two types. First one is the mu2 bridging metal carbonyls and the second one is the mu3 bridging metal carbonyls. To understand the bonding in metal carbonyls, first of all we have to understand the MOED of the carbon monoxide. MOED means molecular orbital energy diagram. During the formation of the carbon monoxide, 1 2s orbital and 3 2p orbitals of the oxygen atom as well as the carbon atom. That means on the whole 8 atomic orbitals combine to give the 8 molecular orbitals. Among these 8 atomic orbitals, 4 are sigma orbitals and other are phi orbitals. Among the 4 sigma orbitals, 2 are bonding molecular sigma orbitals and other 2 are anti-bonding sigma molecular orbitals. Among the 4 phi orbitals, 2 are bonding molecular phi orbitals and other 2 are anti-bonding molecular phi orbitals. In this picture, for convenience, 4 sigma molecular orbitals are shown with 1 sigma, 2 sigma, 3 sigma and 4 sigma. 1 sigma and 2 sigma represents the bonding molecular sigma orbitals, whereas the 3 sigma and 4 sigma represents the anti-bonding molecular sigma orbitals. Carbon monoxide contains 10 electrons in it, and these 10 electrons are accommodated in 2 bonding molecular sigma orbitals and the 1 anti-bonding sigma orbital and 2 bonding molecular pi orbitals. And in this picture we can clearly see the energy order of the different molecular orbitals. In this picture we can understand that the 3 sigma, that means the anti-bonding molecular sigma orbital is the highest occupied molecular orbital, so that's why it is known as the homo orbital, and the 5 star orbitals are the lowest unoccupied anti-bonding molecular orbitals, so that's why these are known as the LUMO orbitals. Here in this picture we can see the HOMO orbital of the carbon monoxide, and in this picture we can see the LUMO orbital of the carbon monoxide. Carbon monoxide gives one lone electron pair present in the HOMO orbital. That means the electron pair present in the anti-bonding molecular sigma orbital to the vacant hybrid orbital of the metal atom and forms a day2 sigma bond. Then after the LUMO orbitals, that means unoccupied 5 star anti-bonding molecular orbitals combine with the filled d5 orbitals of the metal atoms and form 1,5 bond. This is known as the back bonding because here metal atom gives electron pair to the carbon atom of the carbon monoxide, so that's why it is known as the back bonding. And now we discuss about the iron pentacarbonyl. In iron pentacarbonyl, iron is the central atom and the atomic number of the iron is 26 and the electronic configuration is argon 3d6 4s2. And we know very well that carbon monoxide is a strong ligand. So in the presence of carbon monoxide, the 4s2 electrons are pushed into the 3d orbital, and one d orbital is vacated. And this d orbital undergoes hybridization with the 4s orbital and 3 p orbitals, and hybridization will be dsp3, and the molecule gets the trigonal bipyramidal structure. And now we discuss about the chromium hexacarbonyl. In chromium hexacarbonyl, the central atom is chromium, and the atomic number of the chromium is 24, and the electronic configuration of the chromium is argon 3d5 4s1. And we know very well that carbon monoxide is the strong ligand. So in the presence of the carbon monoxide, all the electrons are pushed into the d orbital and the electrons are paired, and through 2 3d orbitals are vacated. These vacated 2d orbitals undergo hybridization with the 1 s orbital and 3 p orbitals and form d2sp3 hybrid orbitals. So as a result, chromium hexacarbonyl gets the octahedron structure. Now we discuss about the structure of the diiron nonacarbonyl. In this compound, 2 iron atoms and 9 carbon monoxide molecules are present. Out of these 9, 3 are engaged in joining the 2 iron atoms. These 3 carbon monoxide molecules are known as the bridged ligands, and other 6 carbon monoxide molecules are linked with only iron atoms, and each iron atom is linked with the 3 carbon monoxide molecules. These carbon monoxide molecules are known as the terminal ligands. The hybridization of iron in diiron nonacarbonyl is D2sp3. This diagram clearly shows us that one bond is there between the 2 iron atoms. Now we discuss the structure of the Triiron dodecacarbonyl. In this compound, 3 iron atoms and 9 carbon monoxide molecules are present as ligands. Out of these 12 carbon monoxide ligands, 2 carbon monoxide molecules act as bridged ligands. And out of these 3 iron atoms, one is linked with the 4 carbon monoxide ligands, and other 2 are linked with the 3 carbon monoxide ligands each. So these 10 carbon monoxide molecules are known as the terminal ligands, and the 2 are known as the bridged ligands. And every 2 iron atoms are linked with the 1 Fe metal bond. So like that, in Triiron dodecacarbonyl, 3 Fe bonds are there, and 2 FeCO Fe bonds are present.